Hey guys, thanks for taking some extra time to check out this video. Not required, but it's definitely appreciated that you're checking it out. In the last couple of videos, or actually in the last video, I said, notice how the a value is always 1 in all the quadratic functions in standard form when we factor. And, just your curiosity might be thinking, well, what happens if a is not 1? Eventually, a couple weeks, we're going to be using this formula called the quadratic formula. And yes, there will be a song attached to it, so you guys will enjoy that. Like you always enjoy all the songs from my classroom, right? So, and usually we'll use the quadratic formula because these can get a little bit tricky and get a little bit messy at times. But I want to do a couple examples with you guys and show you what you can do. And yeah, so let's give it a try. So if we're going to factor this, remember, really, what are you doing when you factor? You're basically just breaking apart the equation so that way you can kind of sift through and find out where are the zeros, where are the x-intercepts. Right now, it might be kind of tricky to see where the zeros would be, where the x-intercepts are, right? Really, the only thing we can identify here is the y-intercept of this quadratic function, which is positive 12. That's really the only thing that's showing right now. So let's go ahead and break this apart. So we have to do this a little bit differently. Before, we would just find what multiplies to 12 and adds up to 19. But we can't do that because this 5, you could try it and you'll see when you multiply it out, it doesn't work. Okay, so we do this a little different, but you'll see some similarities to what we did before. We first start out by multiplying a and c together. So we multiply a by c, and in this case, a multiplied by c would be 60. All right, so 60 is kind of our magic number that we're going to start with to factor. So we think about, okay, what numbers are going to multiply to give us 60, positive 60, and add up to give us 19. So if we run through that list, obviously, I'm going to list it, but 1 and 60 is not going to work. 2 and 30 won't work. 3 and 20, getting us closer, but it's not going to work. 4 and 15 will work, right? Because 4 multiplied by 15 will give us 60. It will also add up to give us 19. All right, so those are the numbers I'm going to use. Now watch what I do here. I don't list it out like we did before. Wouldn't put the x here. What I'm going to do is I'm going to rewrite this equation, but I'm going to use the factors. So I'm going to put 15x plus 4x plus 12. So really, all I've done here, this is an equivalent equation, right? All I've done is I've just made this 19x 15x plus 4x. I haven't changed really anything from this equation other than just that middle term. And really it's identical, right? It's the same. Why did I do that? Well, watch what I did. Notice how I put the 15 here and not the 4. You'd want to have the 15 here because notice how the 5 and the 15 kind of have some common factors. 4 and 12 kind of see that relationship. So you kind of want to put those numbers, as you're working through next to each other, and you'll see why. 5x squared and 15x have some things that we can pull out, a GCF. What would be the GCF? Well, 5 and then an x. They both have an x in common. This is x squared, but they both at least have an x in common. So if you remember back to like GCF, it's kind of similar to that. So we're basically factoring this. So 5x multiplied by x squared, 5x multiplied by x would give us 5x squared. And then 5x multiplied by 3. So see, right here, this is equivalent, right? 5x multiplied by x, 5x multiplied by 3. Okay, keep going. We're going to do the same thing here. 4x and 12, what do they have in common? What's the GCF? It's going to be just 4, not x, because this doesn't have an x next to it. And so then this would just be x plus 3. And if you notice what happens, these are the same. Okay, so these both have x plus 3. So if they both have x plus 3, then we can rewrite this as 5x plus 4 multiplied by x plus 3. Now if you're thinking, wait a minute, how does that work? Well, think about it. If we were to do 5x and 5x here, like distribute, right, that would be the same thing as doing this, right? Think back a couple weeks when we did the box method. And then if I were to do 4 times x and 4 times 3, that's the same thing as doing this, right? So this is an equivalent way of writing the expression that you see above. Okay, that is now factored. So we can see our 2 zeros. One of our zeros would be -3. The other one a little harder to see. Actually, it wouldn't be a whole number, but it's definitely a lot easier to find out what would make this value 0. It's a lot easier to see than maybe looking at it from its original form in standard form. So this would be in factored form. Okay. All right. So let's try another one. A multiplied by C would be -18. All right. And the numbers that multiplied in -18, that would give us a +3. -6 and 3. Nope, that would give us -3, +6, and -3. That would be what we'd want, right? Because that would add up. That would multiply to give us -18. It would add up to +3. So let's go ahead and use that up here and rewrite. And I'm going to want to write my 6 because the 2 and the 6 will kind of have a GCF. So plus 6x minus 3x minus 9. And just a quick check, yep, it's equivalent. 6x minus 3x would be 3x. All right, so now let's go ahead and pull out our GCF. Our GCF here would be 2x. They both have 2x in common. So this would just be x plus 3. Okay, keep going. Subtract. Sometimes with the subtraction and negatives, it gets a little tricky. You might have to erase and just go with it. Give it a try. 3x and 9. They both have a 3 in common. X. And then this would be plus 3, right? And again, these are times where, oh, whoops, I should have put a plus, but just see, right? -3 multiplied by +3 would be -9. Okay, and again, notice how these both have an x plus 3 in common. All right, so we can write this as 2x minus 3, and then x plus 3. And again, why can I do that? Using the same logic we did on the previous question, right? You could just kind of think about multiplying these out. These are equivalent ways of writing this expression. And again, what does that allow us to do? It seems like we keep getting x plus 3, don't we? It doesn't always happen that way, but these two examples it did. So now this allows us to see one of our zeros, one of our x-intercepts would be -3 of this quadratic. And then the other one, you know, and if you wanted to even take this a little further, whoops, sorry guys, it was at the bottom of the video there, wasn't looking at the phone. I mean, you could really think of it. So remember, what we're thinking here is just what makes this whole thing 0, right? What makes the output 0, which gives us the x-intercept? Well, one of them is -3. Well, what would the other one be? Well, you could just do a quick little algebraic equation on that, right? What would make this 0? Well, add 3. 2x equals 3. Divide both sides by 2. X would be 3 over 2, or 1.5. Positive 1.5. That would be the other 0, right? So that would be right here at 1.5. And I mean, if you really want to think about it, the a value is positive, so we know this is upward facing. So we know this has to have some type of shape like that, right? So this quadratic has to look something like that. Okay. Again, I appreciate you guys taking some extra time. This wasn't required, but it's definitely something to think about a little bit. And, you know, like I said, we'll be getting into the quadratic formula that also helps with this process too. So there's more videos online you can search up if you'd like. You just search when a is not equal to 1, factoring quadratics when a is not equal to 1. There's tons of videos out there and practices for you to check it out. All right. Thanks, guys. See ya.